let's discuss some important points. So first one, in a single mission, in a single mission, we can run one or more server or broker. Example, I have one system. In this system, we can run one or more servers. In a single system, we can run one or more servers, one or more server or broker daemons. So I have only one mission. In that mission, I want to create multiple partitions and multiple replication. Then we can start multiple servers in single mission. In a single mission, we can start multiple servers. So we can create replication like example, let's see. Topic I am creating, topic name, big data. For this topic, partitions I am creating three or two partitions. Two partitions I am creating. Replication I am saying two. So replication means duplicate copies. Replication means duplicate copies. Duplicate copy of same partition. Same partition. So partition, we created two partitions, right? Partition 1, we are creating two duplicate copies. Partition 2, we are creating two duplicate copies. Two duplicate copies. So first, why replication? Why replication? Why replication? Fault tolerance. So mainly to achieve fault tolerance. Fault tolerance. So if any partition is lost, if any partition is lost, if any partition is lost, then we can recover from another partition, from another partition, from another partition. We can implement both synchronous and asynchronous. So replication to avoid fault tolerance. So if any partition is lost, we can read data from another partition. So that's why we create multiple server missions. Multiple server missions. So in a single mission, if we start two servers, in a single mission, if we start two missions, server or broker 1, server or broker 1, and server or broker 2, server or broker 2. So we have a topic partition 1, and partition 1, one more copy is available in this mission. So assume this is partition 1 and partition 2, partition 1 only. So we have a duplicate copy in another server mission. So all these two server missions we created in one mission, node 1. In node 1 we started both server 1 and server 2. Server 1 and server 2. If we lost this mission, then so can we achieve fault tolerant? No, right? So we cannot achieve fault tolerance. Yes or no? But just for replication factor, we can create multiple for testing purpose. Testing purpose only we can start multiple servers in same mission. But it is not recommended to start multiple server missions in same mission. It is recommended to start multiple servers in multiple missions so that we can achieve fault tolerance. Okay, for testing purpose, because we have only one system. In that system, we want to create duplicate copies task. For that one, we are starting multiple servers in same mission. Okay, so I will show you multi server creation, how to create multiple servers in different missions. Okay, so I will take in this way I will take VMware. Node 1 is a mission, single mission we call node or mission. So virtual mission, I will create different VMs, VM1, VM2, VM3, like this I'll create multiple virtual missions. Then I will show you, first I will stop one virtual mission. I will stop one virtual mission. Still we can read topic from another virtual missions. I will create different virtual missions in our VMware workstation. I will show how to install Linux operating system, then how to create multiple instances, then how to start servers in multiple missions. Then I will show you how I will stop one virtual mission, then I will write producer application, then I will read topic. Still one mission is down, we can access topic from different missions. Okay, we will do this task also. Okay, first let's see. First start one server in single mission. Next task, we will start multiple missions, multiple servers in single mission. Then we will see actual replication factor advantage. Okay, so first one, so in a single mission we can run one or more server or brokers. This is one. If you are running, if you start if you start multiple server or brokers in a in a single mission for every server or broker, for every server or broker, we need to create separate server dot properties file. We need to create separate server dot properties file. Server dot properties file. We are covering in-depth Kafka workshop, Raviteja. If you see outside, maximum 2 hours they are covering, but here we are covering 8 hours workshop. So end to end we are discussing Kafka development. If you need Kafka administration, contact uh, QT office. Okay. So example, we take like server one dot properties and server two dot properties. So like this we take server n dot properties. So you can start n number of servers in a single mission. For every server we need separate server dot properties file. So while starting server, we execute this command, right? Kafka hyphen server dot property server Kafka hyphen server hyphen start dot back. Then we pass property file. Server 1 we pass server 1 dot properties. This is one window. We open second window. In that second window, command is same. But only one thing, we pass different property file name, so that it will start multiple servers in same machine. Okay, for every server we create a separate server dot properties file. Second one, Kafka server or broker Kafka server or broker runs on runs on unique port runs on unique port unique port number unique port number. So default port number is 9092 9092. So Kafka server or broker runs on unique port number. So default port number is 9092. So if you are running if you are running multiple server or brokers, then in server dot properties files in server dot properties files properties files of each server each server or broker, change port number change port number. First one, in configuration. So in configuration we create separate server dot properties file. In that properties file, first server we use 9092, second server we use 9093, third server we use 9094. Like that we give different unique port numbers to each server. Okay, each server we give unique port number. Next important one, zookeeper zookeeper runs on runs on port number port number 2181. Zookeeper runs on port number 2181. We'll see later. So whatever the way we install in Windows, same, little difference. Only one thing is, here we use environment variable. There in Linux we use bash rc file for updating path and Kafka home. Okay, only Kafka home and path variable we update in .bash rc file. .bash rc file. Yep, everything is same. So if the brokers are running in different missions, port number is we can use 9092 because IP address is different, right? So let's give clear clarity. Once see, if you are running server 1 server 2 in same missions, if you use port number is same, port number nothing but some memory. If you use port number is 9092, it gives conflict. If servers are running in different mission, then there is no conflict. Server 1 runs in port number in IP10 some mission. Server 2 running in different mission, port number is 9092. Okay. So here one of our student question is, can we run server server or broker on different missions with port number 9092. Yes, we can run. Okay, because missions are different. Okay, so yep, IP difference. So zookeeper runs on port number 2181. Then update this port number. Update this port number. Update this zookeeper IP or host name with port number in all server or brokers because so when topic is created it has to update with the zookeeper, right? So when topic is created in server, our server has to communicate with the zookeeper. So for that one we have to update this zookeeper port number and IP address and host name. If zookeeper is running in different mission like this, if zookeeper is running in different mission, if zookeeper is running in different mission, so we need to update IP address and port number in all server.properties file so that each server communicates with zookeeper. Okay, if both are running in same mission we use localhost colon port number is 2181. If zookeeper is running in different mission we update IP address plus port number of zookeeper in server.property file of each server. Okay, so next one, in zookeeper property file we provide zookeeper data directory. First let's see this one. Let's first open server.property file. Go to big data software. So here config and open server.property file. So here every server contain unique broker ID. Let's add that point. Every server or broker has unique ID, unique broker ID. Unique server, unique server or broker ID. We do not have any multiple missions. That's why we are installing in same mission, Sundar. We are running everything in same mission. In first example, we are running in same mission, but in production or real application development, we go this architecture. So we create multiple servers in multiple missions, so Sundar. Only this architecture. Uh, in a single mission, we run multiple demands, right? That is for just for development, testing purpose. Okay. So next one, see, I want to create a first server one. Let's use default configuration. Instead of touching default configuration, I'm creating one file, save as. So server one dot properties, server one dot properties. So here it has to select a properties file. Okay, click on this one. Let's go here, server one dot properties, right? Here I'm modifying. So first one unique ID. Next to type port equal to 9092 9092. Next one, no, it is server one dot proper. Yep. server1 dot properties. Okay, here port equal to 9092. Save and create one more file. Save as server2 dot properties. Server2 dot properties. In this server2 dot properties, use 9093. Let's open server1 dot properties also. Okay, next one. Let's come down. Kafka server writes logs. Message, if message failure, if anything, message writes everything, it write log information. So this is Linux syntax. Then let's provide our logs directory. So I'm creating separate directory in Kafka location. Here I'm creating one directory called logs. Under logs I'm creating Kafka logs. Kafka hyphen server hyphen logs folder. Click on this one, copy this entire path and provide that log path. So create logs directory in your system and provide that log directory. Let's change this syntax forward slash to backward slash. Same thing update in server2 dot properties. How many server dot properties you created, change that one into in all server properties file. Next one, update zookeeper server IP address and port number. So here you will see this one zookeeper dot connect, right? So here we provide zookeeper in running in same mission. That's why we are using localhost. If zookeeper running in different mission, update instead of localhost, IP address or host name, and port number is same 2181. So here also already same thing is available. If zookeeper is running in separate mission, provide IP address of that mission. Okay. And I said our server maintains messages by default 7 days, right? Let's see here. Uh, Log retention hours 168 hours. 168 by 24 hours, right? Then we will get 7 days. So here if you want increase or decrease, add hours, change this time. Okay. So if you want 15 days or 1 month, then uh, 30 into 24 hours, update that time here. Okay. Next, this is size. We can specify size based also in a same mission. So here, this architecture in a same server, I started two server. I want to start two servers. Same mission, I want to start two servers. Server one, I created server one dot properties. Server two, I created server two dot properties. Okay. Next one, coming to zookeeper properties. Zookeeper properties. Zookeeper is running in 2181 port. If you want to run in different port, change this port number. If you want to run zookeeper in different port, change port number here. Update this port number in each server dot property file. Okay, if you want to change port number of zookeeper, update port number here and update this port number in all server dot properties file. But I want to run in same default port number, then change this data directory. I said every zookeeper, everything, producers, servers, consumers, everything communicating and updating information in zookeeper, right? So it maintains some data folder. It stores that update information in one data directory. So we have to provide that directory. So I am creating one more directory in our Kafka installation path. I am creating one directory called data. Under this data directory, I am creating one more directory called zookeeper, and I will update this directory path in in this location. Server data stores in server machine. Here it maintains this data. So this architecture, right? Zookeeper has to maintain about server information, topic information, right? So that information it maintain in this directory. Okay. Yep. Pardon. Yep. Currently it is empty. Next one. Log directory in the since you create uh, when you create any messages in topic, and or if you read any message, or if anything is failure in Kafka server, then it will write a log into this directory, logs directory. So if you want to know what is happened for particular message, then you can open this log directory. You can see different logs. Yep. For every topic, we have separate logs here. Yep. In this location. Okay. Next one, we updated that path information here. That log directory path update information we updated here. Yep. In this directory, it will create file with topic name. In that file, it will write log information. Okay. We will see practically. Okay. Next one. So these are very important points. Next one, for practice purpose, for practice purpose, Kafka provides Kafka provides Kafka provides console producer producer and console consumer for practice purpose. So write everything in a single statement. For practice purpose, Kafka provided Kafka provided console consumer and console producer. For practice purpose, Kafka provided, we will see friend. So for practice purpose, Kafka provided console consumer and console provider. See, this this is provided default console consumer, producer, and console consumer. These are available by default. So this is just for practice purpose, not for real application implementation. So for practice, we can use console producer. Then we can write messages into topic. We can use console consumer, and we can read messages from topic. Practice purpose, they given console consumer and console producer, but real application development, but in actual application development, actual application development, actual application development, we implement we implement We implement producer applications, producer and consumer applications using Java or Python or Scala, etc. First example, we will see console consumer and console producer. Next examples, we will write applications using Java and Python. Okay. If you are using console 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 producer and console consumer, we have to update we have to update we have to update zookeeper zookeeper details in its configuration files its configuration files its configuration files. So if you open conf directory, you will see producer.properties file, consumer.properties file. Then we update zookeeper and uh, server or broker details. Because finally our console consumer or producer responsibility is writing messages and reading messages, right? So these producer and consumers has to communicate zookeeper and server. So that's why we need to provide this information. If you are running multiple servers in same mission, we have to update this servers information in producer and consumer, so that it will go to particular port number and reads messages. Okay. So so let's open and config directory. Open this producer.properties. Here bootstrap servers. This is for updating our servers details. If you are running multiple servers in same mission with a different port number, comma, second server is running in 93, right? If you are running in one more server, comma, 94. Like this, we will update all our server details. In producer.properties file, we update this information. If it is a Java application and Python application, we have predefined class with method function. In that function, we provide all these server details. Okay. Application part we will see tomorrow. Tomorrow we will see how to update these details. If it is a console consumer, Kafka providing console consumer and console producer only for practice purpose. In that, they given separate properties file. So we will update bootstrap server detail. Bootstrap means our Kafka server or broker. Okay. Next one. Next, let's open. So we have only two servers, right? Let's remove this one. Let's open console consumer.properties. Click on edit. Then here update Kafka server or broker details. So 9093. Next, very important note, very important point. replication replication of partition replication of partition less than or equal to number of server or brokers. It should not be greater than it should not be greater than number of servers or brokers. Yep, everything is default is 9092, right? With 9092. Okay. So next, let's see practical one. Practical one. In this practical one, we are using console consumer, console producer and consumer, producer and consumer, and console consumer, console producer and console consumer. We will create topic topic big data with uh, three partitions and replication 1. Replication 1. No, let's first take one server. Let's take one server. In practical one, let's take only one server. So mention that point. We will start in practical one. We will start one server. One server. We will start one server. One server, console producer, console consumer. We create a topic name is big data with three partitions and replication 1. Open separate command prompt for open separate command prompt for command prompt for command prompt for server zookeeper server or broker. And next one, for topic creation and for producer for consumer. So we open different command prompts for different components. We have user guide. Kafka provides Kafka user guide. So let's go Kafka user guide. Let's open these two terminals and we have quick start. So in these user guides, we have for every version we have different user guides. let's go quick start. So we already installed, right? So let's see how to start a Kafka server. So first, to start Zookeeper, we use command start zookeeper server dot server start dot sh for Linux dot bat for Windows. Then we provide property zookeeper properties file. So let's open separate command prompt. Let's close all this one. Let's open command prompt. So this command prompt I am opening for. This command is available everywhere, right? Because of our environment variable set. We set environment variable, right? Because of this command we can run on any location. Next one, configuration path we have to pass. So where is our configuration path? So go to here, this one, right? Let's copy this path and enter that path slash zookeeper dot properties file. So this one, start Kafka server. It will start, sorry, zookeeper server. So we are starting zookeeper server. Observe, it is started. IP address is this one. 0.0 means it's a local host. Local host colon 2181. If our system has separate IP address, if you mention IP address, it gives IP address name colon port number. Okay. Server is zookeeper server is started. Next one, start Kafka server. So let's open another window. Let's open another window. Let's open another command prompt. Here, Kafka server start dot bat. Then configuration path. Let's copy configuration path and enter that configuration path. Okay. So server one dot properties, right? Our file name is server one dot properties. If you are running one more server, open another command prompt. Command is same, but property file is different. If you are running two servers in same mission, then open another command prompt. Command is same. We pass server2 dot properties file. Okay. In first example, we will start only one server. In second example, we will start two servers. Okay. Let's press enter. Then this server communicates with zookeeper and updates this server information. So server is started with broker ID is 0. Kafka server ID is 0. Started. Server is started. Once the server is started, so in this single mission, this is our single mission. In this mission, we started zookeeper, right? We started zookeeper and we started server. We started server 1 with port number 9092. Okay. Then it is communicated and updated this information with zookeeper. Next, create a topic. Create a topic with a number of partitions 3. Replication is 1. Create a topic. Create a topic. Topic name with big data and topic name big data. Topic name is big data. So create a topic. So let's open another command prompt And here we have some topic related commands. Let's open browser and observe. So to create a topic we use command kafka-topics.bat. Let's open Windows. We have kafka-topics. By using this command we will create what? Topics. So let's execute this command. So observe this command. First one, kafka-topics.bat and hyphen create, and we are mentioning zookeeper address. So while creating topic we are updating zookeeper we are creating topic xyz. So this is zookeeper IP address, and replication factor is 1. Partitions initially I am creating 1, and topic is big data. Topic name is big data. Okay, so this statement will create a topic. Once a topic is created, then by using producer we can write messages into topic. By using consumer we can read messages. By using this one we want to know what are the topics are presented in server or broker. Then we have an option hyphen list, zookeeper and hostname. So here we have, if you want to know how many topics are presented in our server or broker, then we use one more command here hyphen list. It will display all the topics presented in server or broker. Hyphen list giving only topic names. Hyphen list giving only topic name. If you want to know how many replicas presented and where is each replica is located, if you want to know complete information, then there is one more command, description. So let's type just only uh, hyphen kafka-topics.bat. It gives some help information. See, these are different options. Hyphen list giving list of all available topics. I want to know complete information of topic. I want to know information of topic. Hyphen describe list details of the given topics. Let's use this command hyphen describe. Hyphen describe. Hyphen describe. Topic name is big data. Let's press enter. See, topic name is big data. Partitions are only 1. Replication count is 1. And topic big data, here it follows while creating topic. One more important point I'll write here. For every topic, every topic, it uses leader and followers concept. Leader and follower concept. Assume we have topic big data with with three partitions. We have a big data topic with 3 partitions and 3 replicas. 3 replicas. 3 partitions and 3 replicas. Assume we have a topic. Assume we have a topic big data with 3 partitions, 3 partitions, 3 replicas. Assume we have 3 servers started. Assume we have 3 servers started. Server or brokers started. Okay. So big data topic we have partition 1, right? Partition 1, partition 2, partition 3, right? So partition 1 has replica. Replica 1 in mission 1, replica 2 in mission 2, replica 3 in mission 3. So like this, for all partitions we have replicas. For all partitions we have replicas. So for partition 1, for partition 1 leader may be this one and remaining are followers. And for partition 2, leader is partition replica 2 and remaining are followers. For partition 3, leader is partition mission 3 and remaining are followers. So in Kafka, not like existed architecture. In existed architecture, we have one specific master means leader and specific slaves are followers, right? But here one partition, one mission may act as leader, some other partitions, other missions may act as leaders. Okay. So so but our mission we have only one server, right? That's why if you observe here in description, leader is 0 means broker id, it's showing broker id. Leader is 0. If we have a multiple servers, it gives complete description about your topic. When you type describe command and topic name, it gives clear description. Here ISR means in sync replica. In sync replica, it shows replica is presented in what are the different missions. It gives that complete information. In next example, we will see we will start multiple servers and we will see once again description. There we will see clear information. Okay. Which mission acting as leader, which mission, which server or broker acting as leader, and which server or broker acting as follower. Okay. So one mission cannot access follower for all partitions. One mission acting as follower only for one partition, for one topic. For different topic, same mission acting as follower leader for partition 2 or 3. Okay. Different topics, different partitions. Okay. We are created only one topic. For the topic, leader is this one, follower is same mission. Okay. So let's so we created topic. Next one, let's start provider and write messages into topic. So to send messages, we use this command Kafka console producer brokers list, and we pass all brokers list. It is optional to pass all brokers list. You can pass only one broker. Let me type this command and let's elaborate this point. Open other command prompt. Type this command See, our topic name is big data, right? Big data. And here, so here, see, hyphen brokers list. So we are writing messages into topic, right? So while writing topic, we are passing servers list. So we have only one server. So in this case, we are passing only one server. If we have multiple servers, it is optional to pass all servers. You can pass only one server. Internally, replication is happen automatically. So partition creation and partition replication is happen automatically. No need to pass. It is optional to pass all servers information. You can pass only one server information. Okay. So let's execute this command. It will open console and wait for writing messages. I am writing message. Welcome to Kafka world. So I am welcoming all of you to Kafka world. So any sample application we write welcome command, right? So welcome. Yep. Welcome to our Kafka world. First example. Okay. Next, press enter. This is my second. This is my second line. Okay. So producer is written messages into topic. In this topic, producer is written message. Producer is written message. Yep. Currently, we are just writing text message. Text message. In some cases, we can write files into messages topics. We can also write files. Okay. You can write JSON object. You can write Java object. You can write Python object. Anything you can write into topic. You can write image. Anything. So currently we are writing text message into topic. So the producer written message into topic. Next, I want to read this message from consumer. So I'll open separate console. I will open separate console. Through that console, I will read this message. Let me open. Let me see that command. So start consuming. This is the command. Let's open command prompt. Let's discuss this command in depth. So Kafka console consumer dot bat bootstrap servers. We are passing any server name. You can pass any server name, or you can pass all server names. And next topic name. Topic name is big data, right? Topic name is big data. Big data. Big data. Uh, assume we removed hyphen from beginning. What will happen? Yep. Let's remove this hyphen big from beginning. Big data, right? Big data. So if I type this command, what will happen? It will first consumer communicates with the zookeeper. Consumer communicates with the zookeeper and reads about big data topic information. So it will display empty. What will happen when you type this command? First, it will enter into zookeeper and finds previous offset number. I said every partition contain offset unique offset number, right? So it will get offset number from here. So once message is readed, then it will update offset number here. Assume we return two message, this message, right? So this message contain in partition 1. In partition 1, this line is assume this offset number is 20. This last line offset number is 20. So it will update this last offset number in zookeeper. Offset number 20. Big data offset number 20 up to offset number 20 I read. It will update that information. Next time if you start the same consumer, it will read offset number, and it will continue from that offset number. It will not read from beginning. Read from beginning. If you want to read from beginning, we need to pass an option saying hyphen from beginning. Hyphen from beginning. Yep. If you not pass this option, it will get offset number from zookeeper and reads continuous message. If offset number is not available, it will not read message. So if you pass this option, it will not communicate with the zookeeper. It will start reading from beginning. Okay. Then update last offset number into zookeeper. It will update offset number into zookeeper. Okay. Let's press enter. Someone asked the question. Yep. In server.properties file, we have a zookeeper details, right? Ramesh. Then, so we have a communication between zookeeper, right? No, we can read from beginning or we can read from continuation part. Or if you want to read specific part, we write customization logics. If it is a program, you can write anything. By using Java or Python API, you can write anything, custom logic. You want to read from beginning, you want to read from middle, you can write custom logic. You want to split data into multiple parts, you can do any custom logic in applications. Okay. So first let's execute this command. So welcome to Kafka world. This is my second line. Let's open producer. Let's open both are parallel. It's reading messages, right? Okay. So in this way, communication is happen. So only practice purpose, they given us console consumer and console producer. This is only for practice purpose. Actual Kafka developer writes producer and consumer applications using any language. Okay. So tomorrow class we will see how to write this producer applications, how to write consumer applications. Already I said that let me discuss one simple scenario. This is my Kafka cluster. Assume I have big data and I have machine learning. This is big data and this is machine learning. So we have two topics, big data topic, and we have machine learning topic. This is big data topic, and this is machine learning topic. Machine learning topic. So big data producer writing messages into big data topic, and machine learning producer writing messages into machine learning topic. And we have, this is Java consumer. So user interface, and we have one more user interface. User interface. Assume this user interface are developing Angular JS. Okay, these user interfaces are developing Angular JS. So middle we have Java producer and .NET, sorry, Java consumer and .NET consumer. Java consumer and .NET consumer. Assume Java consumer reading machine learning messages and passing this message to UI, and here they are displaying nice user interface results. This .NET consumer communicating big data topic and reading messages and passing to UI, and there here they are displaying some message user interface. So in this way applications are implemented. Our part is this part. So we may involved in writing producer side, we may involved in writing consumer side. So you are a machine learning developer. So you are writing some models, and finally that model generate a result, and we are writing that model result into machine learning topic. Then this result is using by Java application for displaying. Finally, we need some user interface. Yep. Simply we can say web service replacement. We can use web service alternative also. So that's what you can create consumer groups, or you can multiple consumers can use same topic. Assume our Java application also using big data topic. A consumer can consume any number of topics. It is not restricted to call only one topic. So that's what in our Java or .NET applications, by using Kafka API, we will implement custom logic. How many topics you want to consume, you can consume. We'll see multiple practicals, plus we'll see installation in Linux, and we will see we will run servers in multiple machines. Okay. UI they will send request. If you see here UI, right, UI has a button. That button calls Java application or .NET application. Internal Java application, .NET application or Python application consumes topics. Okay. Yeah. So this application development follows some architecture, MVC kind of architectures. UI we have UI calls Java application or .NET or Python application. That Python or Java or .NET applications consumes topics. As a developer, as a front end user, he doesn't know where the results are coming. Results are coming from big data. Results are coming from machine learning. They doesn't know. They just see screen. But internally, lot of operations are happening. Okay. Yep. That's it for today.